classify singular points. We have regular singular points and irregular singular point. The difference is we have the definition at the bottom of the screen. But first, we find the singular points. How to find the singular points? We'll divide both sides by this term. So the coefficient of y double prime has to be equal to 1. So we have to have the second derivative by itself. I mean, just that term. And we divide by x squared minus 3x minus 10 squared on both sides. We will have p of x is this, and then q of x is that. Now if p of x and q of x are not analytic, then we have the singular points. So p of x or q of x are not analytic. Then we have a singular point. The function p of x and q of x, if the denominator equal to 0, those functions are undefined. Undefined functions are not analytic. So we say are not analytic if the denominator equal to 0. But since they have the same denominator, so we can say instead of or, it could be and. It not really matters, but because they have the same denominator. Anyway, so we're going to solve for x. The square doesn't really matter. So we have x squared minus 3x minus 10 equal to 0, because the square equal to 0 itself must be 0. So we factor out, and we have x minus 5 and x plus 2 equal to 0. So we have x equal to 5 and x equal to negative 2. Those are the singular points. Now we'll classify them. Let's find x equal to 5 first. Now we have the definition of regular singular point. We'll compute capital P of x and capital Q of x. Capital P of x is x minus x naught. In this case, x naught equal to 5. So let's just say x naught here equal to 5. Use different color. X minus 5 times little p of x. So we have x minus 5 little p of x. We have 7x plus 14. We can factor out 7, and we just have x plus 2. The bottom we have x minus 5 and x plus 2. However, we do have the square here, so we will swap both factors. Alright, what we can simplify here is we can simplify 1x plus 2 and 1 of the x minus 5. Do that, we have 7 over x minus 5 x plus 2 we have that. Now, what we see here is if x equal to 5, now we look at p of x here. Look at this function. If x equal to 5, then it's undefined. So px, capital P of x, is not defined or not analytic at x equal to 5. So it is irregular singular point. If P of x is analytic, we have to go ahead and find Q of x also. But since one of them is not analytic, we don't have to go any further, and we say it is an irregular singular point. Right. Next, we will test the point x equal to -2. And it's actually x0 in this case. We'll calculate capital P of x and capital Q of x. Capital P of x is equal to x minus -2 times P of x. So we have x plus 2 P of x, 7x plus 2 x minus 5 square, x plus 2 square. Right? We cancel x plus 2, which one of them, and x plus 2 with this, and we have 7 over x minus 5 square. So we see that this is defined at x equal to 2. X equal to -2, I mean. So it is analytic. And then because of that, we have to go further and find Q of x. So we do that. We turn into x plus 2 square. Q of x is negative x squared over the denominator. So negative x squared, x minus 5 squared, x plus 2 squared. Right. We cancel the x plus 2 square, and on the top we just have negative x squared on the top, x minus 5 squared at the bottom. Now this function is also defined at x equal to -2. So because both P of x and Q of x are analytic at x equal to -2, x equal to -2 is a regular singular point. Let me write it down. P of x and Q of x are both analytic. So x equal to -2 is a regular singular point. And that's what we have for this problem. So again, we will compute capital P of x and capital Q of x. And if they are analytic at the point, it will be regular singular point. And the point has to be singular first. So we have to compute the regular point, the singular point first, and then we determine if it is irregular or regular. And if one of the P of X or Q of X is not analytic, like in this case P of X is not analytic, we do not need to go any further.